Hello everyone, welcome back to Entrance and Beyond, and today we will be resuming our DSA series, and we'll start off with one of the most famous questions on LeetCode, which is true sum. So let's dive right in. So let's read the question first. So the question states, given an array of integers nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Let's look at a test case. So input nums is equal to 2, 7, 11, 15, and target is equal to 9. So we can see that 2 plus 7 is equal to 9. So we will return the index of 2, which is 0, index of 7, which is 1, and that is our output. Second case, we have nums is equal to 3, 2, 4, target is 6. We can clearly see that 2 plus 4 is equal to 6, so we will return an array with the two indices. So index of 2 is 1 and index of 4 is 2. This is what we return. And lastly, nums is equal to 3, 3, and target is equal to 6. So we can say that the output would be 3 plus 3 is equal to 6. So the output is 0, 1. And over here our constraint is given. So the length of numbers is given, nums of I is given, target is given, and only one valid answer exists. And another thing to note down in this question is they have assumed that only one solution exists and we cannot use the same element twice. So by the same element, they do not mean the same number, they mean the same element. For example, we cannot use index 0 and 0 twice. You cannot say that 3 plus 3 is equal to 6. You'll have to say that 3 at index 0 plus the 3 at index 1 is equal to 6. That would work out, and then they have a follow-up. Can you come up with an algorithm that takes less than big O of n squared total time? So let's first understand the question. The question is simple. We're given an array nums and we are given a target. We have to return indices such that the sum of those two indices be equal to target. So in this case, as you can see, we understood it, right? We have 2 and 7. So the sum of the elements at index 0 and 1 becomes 9, and we simply return that, and this is all that we have to do. So let's try to understand the basic solution. So the basic solution, it is very intuitive, and you can understand that in order to solve the basic version, or the brute force approach over here, would be simple. We look at all the combinations of two numbers. If they are equal to target, well and good, we're going to return the indices. If they're not equal to target, we will not do anything, or we won't return any index. So what I mean is we'll start off at suppose 2. We'll look at the sum of 2 with all the other numbers. So we'll start off at 2. We'll start off at 2, then we'll look at 2 plus 7, 9. Okay. Then we'll look at 2 plus 11, 13. Then we'll look at 2 plus 15, 17. Then we'll look at 7 plus 11, 18. 7 plus 15, that gives us 22. And then 11 plus 15. We'll look at all possible sums of two numbers taken at a time. And as we can see, 2 plus 7 is already 9, so we won't continue. I just use that so you can understand the concept that I'm talking about. So I would recommend you trying the brute force approach on your own. It's simply two loops. That is all that I would like to say. It's one of the most basic ways to solve this question. But now let's try to optimize our solution and understand how we can have a solution that does not take big O of n squared time, which was mentioned in the question. Now this is our number, right? So I want you to notice something. Suppose we're at 2, right? Suppose we are at 2. Now we're at the number 2. Now we know that in order to get target, we would need to find a 7. How? We can say that target is 9. Currently we have a 2. So required number to get a value of 9 would be 7. So suppose we have some sort of data structure where we know that whether a 7 is present in the future or is present anywhere or not. If 7 is present somewhere, we know that we would get the target, right? So I'll repeat that. We start off at 2. We know that we have to if we find a 7, we know that 2 plus 7 will be equal to 9, which is target, right? So can we have a data structure where we can easily look up whether a 7 has occurred thus far in the array? If it has occurred, we know that the target would be 9, and we'll simply return the current index and the index where this second number is located. So you can understand the best way to solve it You might say that we could use a set, but the only issue is that we'll have duplicates, so we can't end up using a set. So we'll use an unordered map. And if you don't know the theory about an unordered map, I would definitely recommend you diving into that a bit, just so that you have a basic understanding. But it's simple. It's basically a key value pair. So it tells we can store a key and we can store an associated value. So that is all that has to be stored. And in this case, we can say that the key would basically be the number, and our value in this case would basically be its index, because we need to return the index in our answer, right? Okay, so I'll show you how it would work in this case. So what we're going to do is we're going to simply traverse through nums. So I'm gonna traverse through nums, right? So we start off at 2. Simple. We start off at 2. We see what number do we need. So we'll simply do target minus current value. So target minus 2. So we need a 7. We'll see in our map if 7 is present. So 7 is not present. If it's not present, no worries. We put the current value in the map. So we take our 2, its index, put it in the map, we get 0. Now we go to the next element, 7. So for 7, we do 9 minus 7. So target minus current value is equal to 2. And we will look into our map. Is a 2 present? Yes, a 2 is already present, so we know that we will get the required target. So what would we return? We'll return our current index. So current index, we can say we'll return the current index and the index of the element that we just found. So over here it's 0, 1 comma 0 is correct, and we can return the answer in any order. That doesn't matter. So that is all that we have to do. So let's try to code it up. So I'll first show you the code in Python, and if you want the C++ code, let me know. So the logic is simple, right? What did I say? I said something very simple. We need to first of all return our output in a array, or we have to return a vector. Since we are using Python, we'll just return a list. So we can say output is equal to, we'll make that an empty list. We'll make output an empty list. Now what we're going to do is, it's very simple. We need a dictionary, right? So we can say we'll have frequency is equal to dictionary. We can use default dictionary, but we don't need it in this case. So we'll have output to store our final output, and frequency to calculate the frequency of the given element. Or this shouldn't be frequency, it should just be index. So I'll name this index. Index will basically store the position of a given number in our array, in our array. So it's simple. We'll run a for loop. So we'll solve for I in range. We can run a simple for loop for I in range. Nums, length of nums. For I in range, length of nums. We take that length of nums, right? We simply take length of nums. We're good to go for I in range, length of nums. Now what do we have to do over here? It's simple. What did I tell you? First of all, we're going to find out required value. So we can say required value is equal to our target minus nums of I. Nums of I is simply our current value at this point of time. Correct? Our current value at this point of time. Now we're going to check. We're going to check whether that given required number is present in our array already or not. So we can do a simple if statement will be used. So if we can say requirement in index, if requirement in index, what are we going to do in this case? So if requirement in index, very simple approach. If it is present in index, we are going to simply do output dot append right. We'll do output dot append. What are we appending? We'll simply append our current index. This would be one thing, and the other thing that we would append is we would do output dot append index. So within index we'll look at the index of requirement, and at this point of time we can break since we have gotten our output. So simple, we'll do break. And in the other case, if that is not the case, what we're going to do is we're just going to do index of nums of I is equal to I. Simple. And over here we have return output, and let's run this code to see how it works. So yes, you can see our code has worked perfectly fine, and our time complex here always be event since we are using a single loop. You can try this code in C++. Hopefully this did make sense to you, and comment down the section or topic that I should discuss in the next video. Thank you so much for tuning in, and yeah.